All right, it is 8:30, so I'm going to go ahead and get started. Good morning. My name is Karen, and welcome to Breaking Science Silos. Thank you for joining us today. I'm excited to share with you guys and kind of just hopefully that you guys will be able to take something from this and apply it to your classroom. If you are able, please consider keeping your video on during this session, just because it's a little bit more engaging to see everybody and their expressions. And we will have a breakout room activity in a little bit. Of course, if things are chaotic in the background, feel free to just communicate via chat. Your microphones are muted by default, but please feel free to ask questions as you see fit throughout the presentation. You don't have to hold them all the way to the end. I am not offended if you want to interrupt me whatsoever. All right, and with that, let's get right to it. All right, so in the time we have together today, we are going to explore integrative models as they relate to content and skill standards. We're going to reflect on how to engage students in real-world applications of scientific concepts. And as I mentioned at the beginning, hopefully we can identify some ways that you can adapt integrative techniques to your own curricula and classroom environments. So what do we mean by integrative? Well, here's the definition that we use here at IMSA. Integrative learning experiences are those which forge meaningful connections of concepts, constructs, and principles within and across academic subjects and real-world situations. All right, so why is integrative learning important? I'm going to start by briefly discussing the difference between instrumental and relational understanding as defined by Richard Skemp. And I did include a link for his article at the bottom here, and I will link it at the end as well. He's actually a math teacher, but I found that his analogy that he provided can be applied to STEM learning in general. So I know we mentioned earlier this morning, we're kind of from all over if you're at the welcome session. So I want you to think about, how do you learn to navigate a new place you've never been before, right? Whether you just moved there or you're only there for the weekend, right? Well, there's two different ways you can approach this. One way is to use our handy dandy Google Maps or Waze, whatever you guys like to use, and you can learn several fixed routes to get from one place to another, whether it's from home to work, from home to school, home to the grocery store, etc. Right? It gives you step-by-step directions. That is an example of instrumental understanding. Okay. The other option, if you're in more of an exploratory mood, right, is you can kind of wander around and kind of just learn how all these different places in this new town or city are connected to each other, right? So you don't necessarily have a fixed path to get from school to work or school to the grocery store, but you know how they're all located in relation to each other. So that's an example of relational understanding, okay? Now, you get to know the city both ways. So what's the big deal? What's the big difference between these two methods, right? It might just be based on personal preference. Well, if you just have fixed plans, right, that means you only know directions based on a very specific set of starting and end points. And if you make a mistake, if you get lost, if there's construction and Google Maps isn't updating fast enough, you kind of lose a lot of time. You don't know how to get from point A to point B anymore because your steps have been completely messed up, right? And so the only way you can recover from that is if you manage to retrace to the last step that you're familiar with and go from there. But if you have a mental map of the city, you know infinite ways to get around. It's okay if Main Street is closed, right? You totally know how to get around that block. You don't need Google Maps to update. You know which general direction you need to go. You know which streets are one way, right? So mistakes, closures, not that big of a deal, right? And so they're much more easily fixable. So why do I bring up this analogy that Mr. Skemp presented? Well, the same thing also applies to teaching, right? We often teach a lot of fixed plans, mostly because that's what state tests are testing, and also because we are evaluated on student progress, right? And so a lot of times we're given, or we're used to teaching things that will produce those high scores or those results, right? However, doing it this way kind of often leads students in a situation where they don't always know how the concepts they're learning, especially in different classes, are connected to each other, right? I'm sure we've all had experiences with students where they can successfully do several practice problems correctly, one after another, and then as soon as you change one variable, they're confused, they're lost, right? Or sometimes you want them to apply something from a biology class into a math class, and their minds are just, they don't know how those two things are related to each other, right? And so that's what I kind of want to focus on today, is how do we try to, still teach our students so that, they are attaining the scores that they need, but also to try to challenge them to draw connections to, different subjects areas, and just to help them build a better cognitive map of what they're learning in school. All right. So with that said, I'm going to put you guys, let's see, into 2 breakout rooms. All right. And we are going to do a brief card sort activity. All right, welcome back to the main room. Thank you guys for partaking in the breakout room activity. I know it's a little bit awkward because we're all doing this digitally. If I had you all in person, you would have laminated colorful cards to lay out however you desired. So thank you for bearing with us in the digital version. If you want, for later, because those are Google slide copies, which you can see the pros and cons of, right? Like the nice thing is that, you guys can all, somebody does something on their screen and someone else in your group can see it immediately. If you would like a non-Google slide version to play with for yourself later, for your colleagues, whatever, I created one where you can open it as many times as you want. Whatever I do on my application will not affect you at all. So if you want one just to play with, it looks a little bit different, but it's still the calendar cards with the colored border. So I just wanted to throw that out there. If you wanted to, go back to this for whatever reason and you don't want to like mess everything up for somebody else, one option is you can make a copy of the Google Slides. The other option is if you want to just save that link for yourself, 100 people can access it and it'll just show up different on everybody's screen. So you don't need to worry about that. Okay. All right. So I enjoyed hopping back and forth between the 2 rooms and just hearing you guys kind of discuss your thinking process, right? Now, here is an example of a completed card sort. I know space was a little constricting, so it looks something like this. I think the one that everybody kind of found helped click everything into place was the yellow one, February, right? Because it's the only one that had 28 days. And then it just became kind of like a lining up process after that. All right, so here's one way you could have sorted the cards. Other people might have done 3 by 4, right? Here's another way you can arrange the cards, all right? And I'm kind of curious, you can say it out loud or you can throw it in the chat. What does this remind you of?
Looks like a clock.
Ah, yes, a clock. All right, and I actually lined it up this way. So remember, yellow was February, right? So that's where the second hand, the 2 on the clock goes as well, right? So if you line it up this way, it looks like a clock, right? And if you wanted to go further, you could also divide it into quadrants. All right, at least in Illinois, this mostly corresponds to the seasons, depending on where you live. It might be shifted a little bit differently, but you could also divide it into fourths to mark the seasons, right? So sorting it this way, right, you could think of the calendar as the clock of the year, all right? And arranging it this way allows you to draw a lot of connections that you probably wouldn't have if you just arranged it the way we normally arrange calendar pages, the way it normally shows up in like a planner or an agenda, which is, just those boxes in a 3 by 4 array, right? Arranging it this way, right, we can line up numbers on a clock with the months of the year. We can divide the year into 4 seasons. For our math people in here, you could have a whole conversation about scales and units, right? We know that there are little tick marks in between the numbers on a clock, right? That can represent minutes, right? If you were to imagine there were all these little tick marks between where December and January were, right? How many tick marks would they be? And what would they represent? And one argument is that you could say, well, I would have 30 or 31 tick marks to represent the days of the month. And finally, organizing it this way allows you to draw the connection that, you know, a calendar year is cyclical, much like the nature of a clock, right? So a lot of different connections you can draw by sorting it in a circular fashion instead of a linear fashion. All right. I know it's a little unfair because on a digital screen, it's hard to sort in a circle, but just wanted to throw this out there. So why integrative? Okay. This calendar sort activity is just one example of a pretty simple activity of how a single lens approach can really limit you from drawing connections to other concepts, right? And we know that integrative learning experiences can help increase understanding, retention, and the most important thing, critical thinking and application of concepts, right? So these all sound nice, but how do we build it in, right? I mean, some math teachers in here might teach about calendars and clocks, but the rest of us, you know, like how can we build in integrative learning experiences? All right, so that's the next part that I'm going to focus on. I like to break down integrative learning into tiers, right? So starting at the bottom, right, you can start by simply just including an example or an extension problem, whether it's part of classwork or homework, with the goal of just showing how whatever concept you are learning in class has to do with something, you know, in another subject area or in real life, okay? To build it up, right, if you don't want to just do one example, maybe you want to center an entire lesson, lab, activity, or project around that area. To build further, right, you could design a series of lessons or maybe even a unit around a singular topic. The ultimate level would be to have a fully integrated course, but this requires a lot of dedicated and coordinated planning. And it's often not really practical for an individual teacher to take this on, just because there's a lot of pieces that are required to get a fully integrated course to work. So if your school has the means to do a full year-long, semester-long integrated course, if somebody's planning that for you, great. But for the purposes of our presentation, I will focus on the areas where an individual teacher, aka you guys alone, can find a way to have this apply in your classroom. All right. So first, I'm going to just list a list of common science topics and some real world applications that you could use to explore either as an example, right, the first tier, either as a full lesson, or maybe even a series of lessons around that topic. This is not an exhaustive list, just some ideas and then examples that I will show you. So if you're teaching, let's say, properties of matter, gases, density, one thing you can look at is the lung and the respiratory system. You can look at how gases differ at different altitudes. So the idea of pressure cooking or altitude cooking. You could also look at pressure changes that happen while flying or just how flight even works. If you're looking at properties of waves, one way you could tie this in is if you want to talk about sound waves specifically, you can look at how things like frequency, wavelength, amplitude, how all those things kind of show up in different genres of music, how they impact the mood or emotion behind that music, and how they tend to show up in either soundtrack or advertising choices, right? It's kind of a fun thing to look at. If you're looking at properties of water, there's a lot of different water safety applications you can look at. You can look at marine health, things that are related to kinetic energy, phase changes, heat transfer. Here in Illinois, I know that my car is covered in road salt, right? A very nice segue is looking at the environmental impact of road salt. If you are teaching about hydrophobic and hydrophilic interactions, right? One of my favorite tie-ins is looking at the different types of cleaners that are out there, laundry detergents, soap, stain remover, right? Why does one thing work better on grass and one thing works better on coffee stains, right? So you can kind of look at what is the makeup of those detergents, soaps, and as well as the dye or stain that you're trying to remove. And finally, if you have an engineering design or makerspace capability in your school, one really nice tie-in is to look at biomimicry. right? Which is essentially designing something for our use based on something that's actually in the wild, right? So maybe what is the most optimal wing shape, right? What is the best swimsuit or wetsuit material? What is the best way to waterproof something? This is not an exhaustive list by any means, just a jumping ground to get some ideas. And I'm going to show some examples on the next few slides, and then we will wrap up. Okay, so I'm going to talk about a few ways you can try to integrate those ideas into your classes, right? So one way is to use current events or case studies, a news story as a means to integrate content in your classroom. It's a nice way for students to see how what they're learning actually, how that matters, right? And it also helps answer the wonderful question we get all the time, when are we ever going to use this, right? So here's a story from, let's see, a little over 10 years ago. It describes how oyster farmers in the Pacific Northwest, so this was Washington State, how they're seeing a dramatic decline in production due to an increase in baby oyster deaths, okay? There are a few different places you can use this story, such as if you're talking about acids and bases, or if you're just looking at human and environmental impact in general, right? So this story, it highlights how they believe that the decline in oysters is because of ocean acidification. So here I'm going to show you a couple ideas for how you can model that in your classroom, right? You can do this through 2 hands-on investigations. And the first thing, you can use red cabbage juice. You can use any acid-base indicator, but essentially you just want to show how there's an indicator that will change color based on whether it's an acidic or a basic environment. So the one in the middle here is just red cabbage juice blended with water. If you add an acid like vinegar to it, it'll turn like a pinkish red. It'll turn more bluish green if you add something like baking soda to it. All right, so, and you can do this with a bunch of household items. The idea is just to kind of build like your own little pH scale, right? To tie that in to the next part, okay, so how does it have to do with our oceans, right? You can again use red cabbage juice or another indicator and have students blow through a straw into that solution. And what will happen is that the carbon dioxide that they breathe out will acidify the water solution, water and red cabbage solution, and it'll turn it more of like a pinkish color towards the pinkish end. It's not going to get as bright red as if you added straight up vinegar to it, but it will shift towards that side, right? So you can have a discussion about, okay, just like with the vinegar, right? The carbon dioxide we're breathing out is causing a shift towards the more acidic end of the pH scale. So that's just part one, the idea that carbon dioxide is acidic, right? Or will produce an acidic solution. The second piece, so how does this have to do with oysters? You're welcome to do the classic, what they call the rubber egg experiment. So you can use normal eggs, or you can use shells, whether you collect them on the beach or if you find them in a craft store. My only warning to you is that you will need to find ones that don't have that kind of acrylic or plastic coating on them that often comes in a craft store. Sand dollars work really well for this. But essentially, you're just going to soak some shells in vinegar. And you should be able to see results, honestly, within an hour. It's very dramatic if you leave it overnight. But pretty much immediately, you'll see that bubbling action, right? So you can, again, kind of have students realize, okay, the acid is doing something to the shell, right? And so you can tie it all together, right, by saying, okay, carbon dioxide output makes something more acidic, which is not good for these shells, right? And so there's a lot of discussions about that can come out of cause and effect and what's happening to the oysters in the Pacific Northwest. To reassure your students that they are still allowed to breathe and that they alone by breathing are not killing the oysters, right? It's worth pointing out that the carbon dioxide we're breathing out is a fraction of an amount compared to the output from, you know, just coal production, greenhouse gases, all of that. So if you have a student that's worried that just by them breathing, they're killing the oysters, feel free to reassure them about that. All right. So again, just a hands-on investigation idea that, and you might even be doing some of these labs already, right? But just, this is a great news story to kind of tie it into how does it relate to the real world, okay? Another idea is to structure your integrative activity as an inquiry or problem-centered learning experience. Doing it this way puts more of the responsibility on the students because they're making the observations, they're gathering the data and evidence, and they're using that data to make sense of it and justify their responses and applying it to a new situation, right? And it also might help alleviate some of the pressure on you as the individual teacher from knowing all the content, okay? So I, like a lot of science teachers, I like to use PhET simulations. The gas properties one is finally HTML5 friendly. So the way I set this up is I just have my students work in groups of 2 or 3, kind of work through it and just look at, okay, how does changing the pressure affect the temperature? How does changing the temperature affect the volume, etc.? And just essentially having them manipulate different variables at a time and come up with their own definition or working model of how all 3 variables are related to each other, okay? Once they've done that, right, I have them go on a macro scale and make a model lung. You can do it with a lot of different materials. If you have a makerspace teacher, this would be a great time to try to collaborate with them. But I just made it with a soda bottle where I cut the bottom off, a straw, a balloon, a rubber band, and then for the bottom, I just took a plastic bag and a rubber band as well, right? And so I then have them tie these ideas together, right? How does the particle nature of gases that you observed in the simulation, how does this apply to the model lung here, right? If you want to go deeper with students, you can have them think about how does this impact deep sea diving, right? The bends. Or you can talk about things like pneumothorax. One dramatic way that I like to model this is simply by stabbing a hole with scissors into the bottle and looking at how it impacts the ability of that balloon to inflate once I pull down on the diaphragm again, right? A lot of different places you can take this. You can certainly add in the mathematical side if you wanted to by giving them actual numbers, or you can just focus on kind of general concepts of increase in pressure, decrease in volume, etc. I've done this as a collaborative unit with the anatomy teacher at my former school, but I've also just done it within my own chemistry classes, and it's gone pretty well both ways. Students have a lot of fun making their own personalized model lung. And again, the inquiry nature of the activity really drives this lesson and allows students to make the connection between gas particle behavior and respiration. All right, you might have noticed that the highlighted activities, they all use safe and affordable materials, and you can get most of them, if not all of them, at the dollar store. And this is important not just from an equity perspective, but it can also make the content seem less intimidating and more relatable to our students, right? I know kitchen science can sometimes get a bad reputation, and even though the activities themselves might be simple, you can scaffold the questions to go as deep as you want, right? And have your students explore what's going on at the molecular level. So I'll leave you with a final activity. You can have students explore properties of permanent and non-permanent markers through various different guided inquiry activities. One idea is to have students predict how well a laundry detergent will get out a stain, as I mentioned earlier, right? Made with a washable marker such as Crayola and a permanent marker such as Sharpie. So here's an example I made. I just drew a shape. I drew a heart on a piece of cotton cloth, and I put it into containers with laundry detergent and left them kind of just during my lunch break. And you can see here already from the side view, right, that there's a difference with how much of that color leaked out into the solution, right? Each one has the same amount of laundry powder and water. I took them out and it looks like this, right? So you can see the original shape on the left is largely intact. You can see a little bit of it came off. And then the one on the right is pretty faded and really is just kind of discolored the entire cloth fabric. But a lot of it has kind of washed out into that solution, right? So, you know, you can do this with other dyes, with other laundry detergent stain removers, but just so you know, I didn't like scrub these or anything. I just drew it, threw it in the container, went to lunch, came back, dug it out with forceps and took a picture of it. All right. If you wanted to, you could also relate this activity to the classic paper chromatography lab, right? And have students explore how the behavior of how a marker separates in water or in a different solution such as rubbing alcohol or acetone, and how that compares to its behavior when left in laundry detergent, right? I've done this with a wide range of students from middle school to AP chemistry. And with younger students, you can just focus on the cause and effect relationships. Why do they think each ink type behaves differently? High school students, you can have them apply definitions of polarity to explain the results. If you really want to challenge your most advanced students, right, you could give them the molecular structures of paper, of water, of the different dyes, right, and have them use that to explain the results. In any case, students follow a simple guided procedure, right? And they make meaning of those observations and try to draw it to something that they're more familiar with, which is, laundry detergent. For my visual people who like graphic organizers, one way you can try to help visualize interdisciplinary connections is by making a topic wheel. It might be useful for you as an individual, or if you wanted to do a collaborative unit with another teacher. So essentially, put a bubble in the middle with whatever subject you teach and the topic that you're trying to teach, and then just kind of branch out around it with all the different possible connections that you could try to make, right? Now, it is worth emphasizing that you don't have to cover all of these. It's just an idea of like, okay, how does this relate to math, to the current news, to social studies, to humanities, right? And then once you kind of see it all out there, it can kind of help have you come up with an idea of, all right, how do I want to do this in my class? So here's an example that I made for Boyle's law, and I wrote the equation there as well. And then here are different areas that you could tie in, right? So if you want to look at math, it's an example of an inverse relationship. If you wanted to pull up current events or news articles, right? Anything that has to do with breathing pressurized air or just breathing in general would be a good segue to talk about Boyle's law. If you want to talk about physics, kinetic energy, elastic collisions, social studies, one area, if you wanted to look at this, since it's called Boyle's law, you can look at how does something become a theory versus a law. English, the easiest thing is to focus on academic writing and supporting an argument with evidence. And then, as I showed you guys earlier, the classic connection with Boyle's law for biology has to do with the respiratory system, right? And you might find once you do one of these that you're already integrating in your classes, which is great, right? All right, final thought that I'll leave with you. If your school uses Danielson as an evaluation tool, and if you need to submit artifacts as part of the evaluation process, components of integrative learning can be found in all 4 domains. Elements of integrative or interdisciplinary learning are listed explicitly in the details for domain 1. And because integrative and inquiry-based activities involve more active participation from the student, you will find those elements listed under domains 2 and 3. So for those of you that do need to check the Danielson boxes, I'm just providing an example of where that might fit in. I know it's not perfect, but All right, some final thoughts that I will leave with you on incorporating integrative learning in your classroom. The first thing I want to emphasize is start by making small changes to what you already do. Don't feel like that you have to start and do an entire integrative unit by tomorrow, right? If you want to just find one example problem to plug into a lesson that you're already doing, great, you're doing integrative learning, right? Or if you already kind of have an idea for a lesson, an activity, a lab, great, start there. It doesn't mean that you have to do your entire curriculum as integrative or interdisciplinary. The other thing to keep in mind is just because you're trying to draw connections to other content areas, it does not mean that the time has to be split 50-50, all right? Whatever content area you're teaching, right, that's still the core subject area. You don't have to dedicate the equal amount of time just because you're trying to apply it to another area. The other thing I want to throw out there is that integrative and inquiry-based activities, they're still structured, and you can still make them largely structured and have students follow a guided procedure. The key thing is that you're not giving away what they're supposed to find out, right? But they need enough guidance to, if they're supposed to do a lab, they need to know how to set it up. right? Or at least they need some practice with that before they are capable of designing their own procedure, right? So it's okay to have them still follow a guided procedure. The key thing really is, what analysis questions are you having them answer? How much are you having them analyze their data? And finally, I know I spent today talking about how, relational understanding and integrative learning, drawing connections, super great, right? But there is still value in instrumental understanding. I mean, we can't get away from the fact that there are certain concepts you're just going to have to memorize before you can apply it to other content areas. So don't think that you can't give students step-by-step things ever in class. All right. And I'll leave you guys all with the question, what does blank have to do with blank? As you guys kind of embark on this journey of trying to tie in, other real world applications, connections into your content area. And these are my references in case you are curious. And that's it that I have for you guys. Thank you much for your time and attention, for your collaborative work with each other in the breakout rooms. As mentioned in the morning session, if you want the CPDUs, and I'll drop these links into the chat momentarily, you will have to fill out 2 eval forms. They are also available on our website as well, on the Institute Day website. One is for ISB and one is just internal for us. Our website for other PD opportunities and events. And obviously, if you want to contact me for anything, I've left my email there as well.